Is 4.3 Logarithmic Properties, Part 2. Okay, so we covered Logarithmic Property 1 and Property 2, and now this is Property 3, the power rule. This rule says that if you have a log of a number with an exponent, then it's the same as if you have the product of that exponent and the log of the number. So let's look at an example. Let me first show you up here. If I have log base b of m to the p power, it's the same as if I said p times log base b of m. So notice that p just came around up front. Okay, so down here they show us natural log of x squared is the same, take that 2 and take it out front, of 2 times natural log of x. And you'll see where we'll start using all of these rules together. So let's apply it. It says use the properties of logs to expand the logarithmic expression as much as possible. All right, so we have log base y of x cubed. I know I can take that 3, take it up front, and that would give me 3 times log base y of x. And then I'd look, is there any other place I can simplify? Y raised to the what power would give me x? Well, I don't know because those are both variables, right? So I would just leave it be. And that would be my answer. Okay, so this one we have the fifth root of x. So digging back into maybe unit 2, I think we dealt with this, where we said, okay, if you take this number, which is the index of the root of a value, you can rewrite it as an exponent. So there is a 1 here because we don't see anything, right? If there was an actual number there, then it would be that number. But what we do is we drop the radical, this symbol right here, and we take the index and plop it underneath this number and make it a fraction. So the fifth root of x is the same as x to the 1/5. And just to show you that this over here, if I had the cube root of x squared, I would take that index, plop it in the denominator, and have x to the 2/3. Okay. All right. So now I have it as an exponent. Once I get that root expressed as an exponent, now I can apply my third property and put it up front. So remember, if I have a log raised, if I have a log of a number raised to an exponent, it's the same as the product of that exponent and the log of the number. If I could further simplify, I would, but I cannot. So this is just sort of kind of like your log properties cheat sheet. It just sums it up. Remember that we had the product rule. So we said, okay, when we're multiplying two values inside of a log, it's the same as taking that log of each number and adding it. So the sum of those logs. If I have division going on inside of my log, it's the same as subtracting those two values, but you have to make sure you carry over that log in front of each of them. Okay. Then this one right here is saying, okay, if I have an exponent, then I can take that exponent and plop it down in front. And then, oh, it's the same thing. I have an exponent. It's just fraction, but I took it out front. But that's showing this last one where if we had a root of a number to change it, to express it as a fraction in the exponent. Okay, so now we're going to put it all together. It tells us to use the properties. Okay, so very first thing I'm going to do is, and they're telling me to expand. So remember that if I'm expanding, then I'm taking one log into multiple logs, right? So I'm going to go ahead and first get everything out of the parentheses. So let me rewrite this a little bit bigger. Okay, so using the quotient rule here to write multiple logs. So square root of g minus log 9 of 81. Okay, now I want to see if I can simplify, right? Well, I see that square root, and I know that that square root of g can be expressed as g to an exponent, right? We don't see it, but when we don't have a value there for the index, we understand that it's a 2, it's the square root, and then when we don't see an exponent there, we understand it to be 1. So now I'm going to have log 9 g to the 1/2. And then over here, I'm going to have subtract. Look at this. Remember, if I can express that 81 as a base of 9, which I can. So if I can express it in exponential form with a base of 9, then I can simplify this out. So this would just be 2. If that confuses you, or also to check, well, let's check it out. So we're not going to use our common log. That's just the button on the calculator. We're going to go ahead and let me exit out so we can see all of it. I'm going to press F4 for math, and then F2 for log AB, which gives me the boxes. We had log 9 of 81. And watch this. It pops out 2, right? Because 9 to what power is 81? 9 to the second power is 81. So log base 9 of 81 would be equivalent to 2. All right. So I simplified that portion of it, but remember we have this going on right here, and I could take that to the front. So 1/2 log 9 of g minus 2. And I'm going to put this in parentheses. I noticed that I wasn't doing it in the first portion of 4.3. The reason that that's a good habit to have is so that there's no misunderstanding of this being log 1/2 times log base 9 of g minus 2. The log base 9 is only of g. So putting parentheses around that will be helpful. And that's your answer. There's no other place that we can simplify. Okay, so we see that 7th root, right? So definitely wanting to first knock that out. So let's do that first. Let me write. So let's go ahead and separate those radicals. So we have common log. So I know there's a base of 10 right there, even though it's not showing it. And then okay. Now I can go ahead and use the quotient rule. So because there's division going on, I can have subtraction between those logs. And then express this as an exponent rather than a radical. And then take these to the front. So 1/7, that one was tricky. 1/7 log of s minus 1/7 log of t. So separate radicals. Use quotient rule. And then use the product rule. So if you don't know the name of the rule, that's okay, but do know how to use it. Do know how to apply it. Okay, this one looks really ugly, I know, but if I was to give you individual parts of this, you would know how to do it. And if not yet, then you would after practicing it. So let's just tackle it step by step. First of all, I go up to see what are they even asking me. So they're saying use the properties of logs to expand the logarithmic expression. So I know that I'm going from one log to multiple logs, yes? So the very first thing I'm going to do is I'm going to get this expression right here. And instead of it being underneath a radical, I'm going to change it so it's expressed as, it's expressed in exponential form. So it's not going to look too different. I'm still going to have 10 times x to the 4th. And then the entire expression that's underneath the radical up to the 1/3. Be careful that you don't just put it to the 3rd. It might help for you to put parentheses around here and say, okay, there's no power on the outside, so this is to the 1st, and then I'm taking this 3 around and making it to the 1/3. Doing that notation for a while might help so that you don't just take that 3 and accidentally say, oh, it's up to the 3rd power. Okay, and then at the bottom, I have 7 times x plus 3 squared. So the next thing that I'm going to do is I like to identify my factors because I'm about to expand this and have multiple logs. So I want to see every place that I need a log. So I need log of 10, and then this is being multiplied by x to the 4th, and then this is being multiplied by 5 minus x to the 1/3. Then in my denominator, I have 7, and then my other factor is x plus 3 squared. Okay, so now I see all my factors. I have the ones in my numerator, which I know will be positive, right? And then I'll have the ones in my denominator, which I know will be subtracted. So common log of 10 plus, it's positive because I'm still in the numerator, common log of x to the 4th plus, and I'm still not putting parentheses around them. Okay, plus common log of 5 minus x to the 1/3. Okay, I hit all of my factors up in the numerator. So now let's go into the denominator. So minus common log. So I'm just using whichever log was here, right? 7 minus log of x plus 3 squared. Whew, okay. Now let's see what kind of simplifying we can do with those. Well, common log of 10, I could do the math of that by hand, but I also could just say, let's see if we get an integer when I punch that in. Common log of 10, yes, I do. It's equivalent to 1. And that makes sense, right? Because there's a 10 right here in a common log. So 10 raised to the 1st power would give me 10. All right, so 1 plus, okay, I know that my exponent rule says I could bring that up here. 4 times log of x plus, same thing here, exponent rule says to bring that in front of the log, 1/3 log of 5 minus x minus, let's see if log 7 gives me a nice number. The way I think of it is 10 to what power would give me 7, and that doesn't make me feel warm and fuzzy, right? Like, oh, that I think that's a power of 10. It's like, nope. And sure enough, we get this 0.84509. So it's an ugly number. So the only way we can express that is by keeping that log. Okay. And then minus, I'm able to bring that 2 times log of x plus 3. And we're done. We're done because we cannot simplify any of those individual logs any further. There's nothing more we could do. So that was expanding. Now on this one, they're asking us to condense. So they want to go from multiple logs to 1 log. And here we're using a natural log. Right now, notice that, I'm going to rewrite this a bit bigger. Notice that I have, sorry that's so crooked. A 5 in front of my first natural log and a 3 in front of my second natural log. So I'm going to do the reverse. Using that exponent rule, I'm going to take it up to the top. Don't take the negative. That's just signifying that we're going to use the quotient rule. So now I have natural log of x plus 6 raised to the 5th minus natural log of x raised to the 3rd. Condense it to 1 log. My positive portion will go up top. So x plus 6 to the 5th. And the part that's being subtracted will go on the bottom. Of course, without the log, because we already accommodated that in the front. X cubed. And that's my answer. I promise you, the more you do these, the better it gets. I'm not going to say you're going to be a pro at it, because maybe you won't, and that's okay. But the more you practice, the less foreign it feels. So practice, practice, practice. Okay, so they're asking us to use the property of logs to condense. So I know that I'm going from multiple logs to 1. I'm going to write this a little bit larger. And I'm going to start using my rules to pull things in together. Okay, well, I'm going to leave that 1/8 out front until the end, so I'm just going to worry about what's inside. I know this can go up here, right? Anything else? No. So in the next one, only this changed. Okay. Now I'm going to go ahead and take it to 1 log. So this one is positive, so it'll be up top, x plus 3 to the 5th. This one's being subtracted, so it will go at the bottom, x. And then this is being subtracted, so it'll go at the bottom. Okay. Okay, but we're still not done because we have to use our power rule, our exponent rule. Don't worry about distributing that. So now I have 1/8. And then do you remember the steps when we were undoing all this, right? When I have a fraction in my exponent, before I would take it to a fraction in the exponent from a radical. So now we're going to take it from that exponent and take it to a radical. So remember, this stays put. This bottom one goes up front. So the eighth root of x plus 3, goodness gracious, over up to the 5th over x times x squared minus 25. And that would be your answer. Practice, I promise, it gets better. All right. So this is telling us to use our common logarithms or natural logarithms and a calculator. So literally you could take your calculator, watch this, and we see that it's not a natural log. Let me delete all this out. It's not a natural log. So I can't use just that natural log, or I'm sorry, the common log button on my calculator, right? So I'm going to go ahead and press Math, F4, and then F2 for log AB. And then my base is pi, so I just input that. Shift, get that pi in there. And then of 65. We get 3.646613, yada, yada, yada. It keeps going. They tell us to evaluate to 4 decimal places. So that would be 0.6466. And you're done. After all that work in those last 2 slides, I think we deserve this slide, right? Where we're like, okay, let the calculator tell me. So just make sure that you understand, like, okay, I'm just plugging it in. Okay, this gets a little tricky, but I think after I explain, it'll be better. So it says, let log base b of 8 equal g. So any place that I see this, I can replace it with just g. That's what it represents. And then log b of 7, if I see that, I can replace it with x. And then they want me to write this expression in terms of g and x, okay? So I don't have that specific expression in this expression initially, right? I have log base b of 7/8, but I don't have log base b of 8 or log base b of 7. But I can use my rules to get there. So I can go ahead and use my quotient rule. And I can say log base b of 7 minus log base b of 8. And now look, where I see log base b of 8, I can replace that with a g. And where I see log base b of 7, I can replace that with a x. And that's what they're saying. They said write the expression, but write it using these terms. Okay. This one is similar, but be careful because it's a bit misleading because we used both terms in the last one. So it says let log b of 9. If I see that, I can replace it with t. And then log base b of 10. If I see that, I can replace it with s. So they say write the expression in terms of t and or s. Okay, so we can either use both of them or one or the other. So I don't see in my initial log that's given to me log base b of 9, nor do I see log base b of 10. But I can express 81 as 9 squared, right? And with my exponent rule, I know I can take 2 to the front, so I can have 2 times log base b of 9. And look, this is 2 times, right? Log base b of 9, and that can be replaced with t. So my answer would be 2t. The question on this slide is usually, so where did the log base b of 10 go, or where were we supposed to use that? You weren't. It was just saying you could use and or. So it's a little tricky there. And a little math humor. So go ahead and condense these. Remember with our product rule that when we have these logs that are being added, so the sum of these logs is the same as if I was to condense it to one log and then just the product of all those. So I have C, A, B, I, N, and I have log Kevin.